Today, the problem that we're going to be covering is called depth first search. And what this problem is asking is that it says you're given a node class that has a name and an array of optional children's nodes. When put together, nodes form an acyclic tree-like structure. Implement the depth first search method on this node class, which takes in an empty array, traverses the tree using depth first search approach, stores all the nodes' names in the input array, and returns it. If you're unfamiliar with depth first search, we recommend watching the conceptual overview, yada yada yada. Right? So first, let's talk about what depth first search is. Right? So depth first search is exactly what it sounds like. Right? So it goes depth first, meaning instead of going across the tree from left to right, right, it goes deep first. So for example, a depth first search of this tree, right, would go A and then B and then E, then F, then I, then J, all the way back up to C, then to D, then to G, then to K, and lastly H. And if we scroll down, that's exactly the order that would be our output, right? So essentially you're going on the left, you're going left as deep as you can first, then you slowly start to traverse your way right and go deep on right. So that's basically what depth first search is. If you know that explanation didn't suffice, please like look it up. This is like something that you should really know back to front, and you really should understand both depth first and breadth first search for any coding interview, because it's really a baseline topic that comes up a lot, right? So again, after reading the problem, I think we can sort of guess that this is going to be a tree traversal problem. Um, so let's start writing some comments. Oh, and then one other thing I wanted to point out here is, so usually in problems that I've covered before, the node has a value, and then it also has a left node and a right node, right? This case is actually different, right? You can see that this node class has a string name, so this could suffice for our value, but the children, there are no left and right nodes in this class. There's only a list of other nodes that signify children, right? So I think it's important to say that this children array list is going to be represented from left to right, meaning if we're past the node A, right, the name is going to be equal to A, and this array list is going to contain the values B, C, and E. B, C, and D, sorry, right? So that's one thing that's really different than in this problem versus some of the other trees and tree-like problems that I've covered on the channel. So yeah, so starting out, anytime I do a tree traversal problem, I like to create a helper method to do any recursive step. So we're going to create helper method, right? So let's try and stub out what this helper method is going to look like. And this helper method is really going to do our recursive step and all the business logic that goes along with it. Um, let's call it depth first search helper, right? And one thing that we know for sure is that we need to populate this array that's given to us, right? We don't create a new variable, we don't create a new list and return it. The question specifically asks us to take this array and populate it and then return it back to the user, right? So we know for sure it's going to take in list string array because this is what we need to populate. And then the other thing the helper method is going to take in is a node class, right? And this node class is going to be represented by n, which would be the node that we're currently looking at, right? Now, since we have our helper method, we're going to call it like this. So depth first search helper, we're going to pass in array, and because we are within the class node, right? This method is being stubbed out within this class node, right? Let's shrink this a little bit, right? We're just going to pass in this, right? Because essentially what we're assuming is that this would be the root node of our acyclic tree-like structure, right? So we're just going to pass in this, right, which is a node. And then we're going to have a base case check, like in any tree traversal problem. And the base case check is going to say if n equals null, then return, right? So you're not going to do anything. We're just going to return, right? So let's think about what the first step in our business logic should do, right? So the first thing we need to do is first we need to add our value to the result array, right? And result array, right? We can call this result if we want, right? So what we're going to do here is we're going to say result. Let's call it result list, just to be explicit. Result list dot add, and we're going to take the node that we're currently looking at, which we assume to be the root that we're passing in, and we say n dot name, right? So we're going to add the value of the node that we're currently iterating on to our result list, right? Okay. And then here comes our recursive step, right? So we need to iterate. So once we have our node value, right, we're given the name and a list of node children, possible node children, right? It is possible for this array list to be empty, right? And like I said before, this list of node children is going to be ordered from left to right. Meaning for, let's say we're at this node A right here, just to explain this once more, this list of node children is going to be structured like this. B, C, and D, right? So that this is what, oops. This is what this is going to be equal to, right? So because we know that the list of children goes from left to right, instead of iterating recursively, we have to iterate through a for loop recursively, and I'll show you why. So we iterate through the node children array from left to right. And remember what I said about depth first search. It's a traversal a pattern that goes deep first, but it goes deep on the left side first, right? So what we'd say is we say for each node, we'll call it child in n dot children, right? So for each child for this node, what we're going to do is we're going to call depth first search helper. We're going to pass in our result list, right? And then we're also going to pass in child, right? And then that is all we need to do, I believe. So let's take a look at this, right? So, okay, so we created our helper method. This helper method is going to take in this array list, and it's going to take in the current node in this object. Then it'll just return the modified array list. So the helper method, it does this base case check. The first thing we need to do is we need to add the value of our node to our result list, right? And then through this for loop, we're going to iterate on each node child from left to right, right? And call our depth first search helper recursively. All right, and I think that should work. Let's make this up. Yep, 5 out of 5 test cases pass, and submit code. Cool. So it looks like that's a viable solution. And again, the reason this works, this is probably the meat of the algorithm right here, recognizing how to traverse through the children, given that it's a list of nodes, right? I think it's important to realize that this list of nodes is all the children for each node from left to right. And in this case, order does matter, right? Because let's say we're at this node A. This node A has 3 children. B, C, and D, right? On the first, in this for loop, the first child that it's going to take from this for loop is B, right? Then recursively, it's going to take E, right? Then it's going to go to F, I, J, C, D, G, K, and then H, right? And it's going to do that by going from left to right. Thanks for watching. Hope you guys enjoyed the video. Like, share, and subscribe.